Dear learners, I'm going to deal with one of the topics of microbial biotechnology, that is production of antibiotic penicillin. Myself, I'm Dr. Jyoti Supar, working as associate professor in Department of Botany and PG Studies, Government Science College Autonomous, Rupatanga Road, Bangalore. Introduction. Antibiotics are antimicrobial agents and they are produced naturally by microbes. The first antibiotic which was discovered was by Ernest Duchesne in 1896. In 1928, Alexander Fleming he rediscovered the antibiotic penicillin and he obtained it from the fungus Penicillium notatum. This antibiotic penicillin was purified in 1940s by H. Flory and by E. Chain. Penicillin was the first important commercial product and this was produced by aerobic submerged fermentation, and this was produced by fungus Penicillium crassogena. Now this is a petri dish which shows the pure culture of Penicillium chrysogenium, and this is a diagrammatic representation of the fungus Penicillium, the vegetative hyphae, and showing the asexual reproductive structures of Penicillium, that is conidiophores are present which bears the medullae, the sterigmata as well as the basipitally arranged conidium. Types of penicillin. There are different types of penicillins. This penicillin, it is represented by the general formula C16H18N2O5SR, where R represents the radical or an alkyl group. Now penicillin F, penicillin G, penicillin X and K, these are produced by the strain of Penicillium notatum crassogenium group of the molds. Now let us look into the structure of penicillin. So as you see in the pic, penicillin, it consists of two rings. One is thiazolidine ring, and this is condensed with the beta-lactam ring, and at the 6th amino position there are a variety of acyl substituents. Naturally occurring penicillin is 6-APA, that is 6-amino penicillic acid. Now let us look into the properties of penicillin. It exhibits the properties of a typical secondary metabolite. This penicillin is active against certain gram-positive bacteria. It is soluble in water, acetone, ethyl alcohol, ether, etc. But it is less soluble in benzene and chloroform. Aqueous solution of penicillin is unstable and therefore it must be stored under refrigeration. Penicillin is stable at the pH range of 6.0 to 6.5. Now let us look into the fermentation biotechnology for penicillin production. Naturally occurring penicillins, they are produced when fermentation is carried out without any addition of the side chain precursor. If we want to get derived penicillin, then we need to add side chain precursors. Synthetic penicillins, they are produced by enzymatic hydrolysis of 6-APA by penicillin acyclase enzyme, and this results in the addition of the desired side chains. Beta-lactam thiazolidine ring of penicillin, this is constructed from two amino acids, that is L-cysteine and L-valine. Now these two amino acids, when they are combined with L-alpha amino adipic acid, then alpha AAA, that is the tripeptide, is formed. This then undergoes two-step cyclization process to give what is called as the isopenicillin. Now let us look into the industrial production of penicillin. It is produced by different methods. One is by surface process, that is solid state fermentation, and surface liquid fermentation. Commercially, it is produced by fed batch process. The inoculum or the microorganism used, as we have already discussed, is Penicillium crassogenium, which is the improved strain. Inoculum preparation. The spores from heavily sporulated working stalks, they are suspended in water or they are suspended in non-toxic wetting agents. These are then added to the flask which contains the media that is the wheat bran and the nutrient solution, and this results in the heavy sporulation. It is then subjected to incubation for 5 to 7 days at 24 degree centigrade. The spores which are produced, they are then transferred to the seed tank, and incubation is done for 24 to 48 hours at 24 degrees centigrade along with constant aeration and agitation. Now what happens is the mycelia is produced and within the fermenter. Now let us look into the actual process of fermentation. So method used is the fed batch method or the batch fermentation. Substrate used is glucose, phenoxyacetic acid, corn steep liquor. Additional nitrogen sources, for example soya meal or yeast extract is added. Also lactic acid, inorganic ions and growth factors may also be added. The fermenter which is used is a stirred tank or the airlift tank. Now this is a pic which shows the batch fermenter. So this is the vat or the fermenter. Into this the media is taken and the starter culture is added from above, and all the suitable conditions required for fermentation are maintained within this batch fermenter. That is the suitable pH, the temperature is all maintained, and as the fermentation proceeds, what happens is the temperature goes on rising. In order to maintain the temperature surrounding the fermenter, there is a cooling jacket. The churning or the mixing of the media with the starter culture or the inoculum is done by means of what are called as the impellers. So this is the impeller. This is connected to the motors, and this ensures the impellers ensures the proper mixing of the inoculum along with the nutrient media to bring about the fermentation. And whatever harvesting is done from the lower side of the fermenter. So when the process of fermentation proceeds, then periodically about 30% of the media will be harvested, and it is then substituted by equal amount of the fresh media which is added from the top. Now you can see over here in the pic, this is the batch fermenter. The starter culture is added and also the media is added. The fermentation is brought about for a couple of days. Periodically, as I've already told, at one time 30% of the media will be harvested, which contains the penicillin, antibiotic, as well as the fungal cells. So this is then filtered. The broth which is obtained, it is filtered, and the fungal cells, they are removed and they can be used as the animal feed. Whereas the filtrate, it contains the penicillin. Now this penicillin is present in the broth, and so it has to be separated from the media, and this is done by dissolving it into butyl acetate. Later on, potassium ions are also added so that the potassium salt of penicillin will get precipitated. Then this salt is then washed, it is filtered, and it is dried to get 99.5% pure penicillin, and later on it can be used as such, or if any modification or different type of penicillins, or that is derived penicillins, are required, it is processed or modified in the subsequent steps. So the pH is set at 5.5 to 6.0. It may increase to 7 to 7.5. Temperature is, as we already discussed, it is 24 degrees centigrade. It may range from 25 to 27 degrees centigrade. Aeration is zero point 0.5 to 1 BVM. Agitation is about 120 to 150 RPM. The time required to complete this process of fermentation is about 3 to 5 days. Antifoaming agents, for example, edible oils, that is 0.25 percentage, is also added. Product recovery. So the broth is harvested by means of filtration, that is done by the rotary vacuum filtration. It is chilled to 5 to 10 degrees centigrade. The filtrate is then acidified with the help of H2SO4, and the pH is brought to 2.0 to 2.5. The penicillin is extracted into butyl acetate. This organic solvent is then passed through charcoal in order to remove any impurities that are there. And then again the penicillin is re-extracted in 2% aqueous phosphate buffer at pH 7.5. Then the aqueous fraction is acidified, wherein the pH is brought down to 2 to 2.5 by adding of the mineral acid. And again the re-extraction of penicillin into fresh butyl acetate is done. Along with this, potassium acetate is added to the solvent, and then extraction is done in the crystallization tank, and then the potassium salt of the penicillin is crystallized. These crystals are then recovered by filtering or by means of centrifugation. It is then sterilized, and further processing and packaging of the penicillin is done. Finally, let us look into the clinical uses of penicillin. This penicillin is effective against gram-positive bacteria, and some of the derivatives or members of the penicillin, that is amoxicillin, they are also effective against gram-negative bacteria, and they are used for treatment of bacterial endocarditis. This is the peak of the human being, and you can see over here that penicillin can be administered by both the routes, that is by oral route as well as by the IV method, that is intravenous. So penicillin can be used in the treatment of otitis media. It can be used in the treatment of meningitis. Then it can be used in treatment of sore throat, in treatment of pneumonia as well as respiratory tract infections. It can be used to treat septicemia. It can be used to treat peritonitis as well as gonorrhea as well as the urinary tract infections. To summarize, antibiotics are the most important group of compounds which are synthesized by the microbes. Medically important antibiotics are beta-lactam, penicillin, cephalosporins, etc. Penicillin is commercially produced by a fed batch process, and this is carried out aseptically in stirred tank fermenters. These are the references that I have used to prepare this presentation. Thank you.